All right, my name is Rob, and this is chapter 42. Oops, this is chapter 42, problem number 44. You've got a helicopter, it's moving above the ground, and it's got some weird equation for its position. And then it says after 2 seconds it releases this mailbag, and how long for the mailbag to reach the ground. The first thing I want to do is probably draw a picture. And what I'm first going to do is draw the helicopter in, how about some purple, okay? So here's a helicopter. Okay, whatever. Here's a helicopter. And it's got this mailbag right here. Okay, so there's the mailbag. Initially it's sitting on the ground. Then at some point the helicopter is going to move up. The picture is going to get worse. Here's the mailbag. All right, and at this point it looks like the helicopter is moving upwards. Okay. And we know the helicopter is some distance above the ground. Let's say H. Okay, so it's some distance above the ground, H. And then what's going to happen is at this split second here, when it's exactly at some height here, we could call this H0 actually. All right, because that's when the mailbag is going to get released. Let's change the pen here to green. Okay, here's the mailbag. Now I'm just going to draw what happens to the mailbag. Which way is the mailbag going to be moving? It's not released from rest. It's actually moving upwards, so that's a tricky spot. It's going to be moving with some speed, v0. And as a result, it's going to follow some path like this, all the way back down here to the ground. And so what the question is asking is, how long to reach the ground? So it's asking for t. How long is asking for about, whoops, geez, it's asking for time. And notice, you can see I just made a mistake there. I wrote down 2 seconds, but t is not 2 seconds. This time, to get from here to here, let's put this in red. The time from here to here, that time is 2 seconds. That's not the same as this time, okay? So now what I might do is I might say, okay, let's go back to our small pen here. Now let's do the equations in a different color too. Let's pick this pink, okay? So now what we know is, let's see, we have the height initial is equal to 3 times t cubed, which is going to be 3 times 2 cubed, which is 8 times 3, that's 24 meters. The velocity, how am I going to figure out the velocity? In this case, you might put in that v is equal to v0 plus at, but this is a bad method. It turns out in this case, for the stage right here, for this point in time, a is not a constant. No. Okay, so that means we have to get the velocity the old-fashioned way, which is take the derivative with respect to time of h, which in this case is going to be 9t squared. Because if you take the derivative of that, you get 9t squared. Okay, which at 2 seconds, that would give us the initial speed here. It implies the initial speed of the mailbag is 9 times, let's see, 2 squared, which is equal to 36. And it's upwards, and that's meters per second. All right, so now we're finally ready to look at the mailbag, and we know that y final is equal to y initial plus, let's see, 1/2 at squared plus v0 y times t. We know that y final, listing out our knowns and unknowns, is 0. Y initial is equal to 24. v0y is equal to 36. Let's see. The acceleration of the mailbag. What is the acceleration of the mailbag? Do I need to take another derivative? No. The acceleration of the mailbag has to do with this part of the problem. See over here? Over here, A is equal to negative 9.8 meters per second squared, because the mailbag is in free fall after it leaves the helicopter. You can see there's tons of pitfalls in here, all right? So we say that's negative 9.8 meters per second. Squared. I'm running out of room here, so let's scroll down a little bit. And let's put the final result in some different color. Let's see, whoops. Change the pen. Let's go to some other color. Let's go black. What the heck? All right, so we get this equation. Plugging in our knowns, we get 0 is equal to 24 plus, let's see, 1/2 times negative 9.8 meters per second squared. Notice that it's negative g and not g. This is meters. And then plus 36 meters per second times t. What did I forget over here? A t squared. Bad, Rob. All right, so when you do this, you can do the quadratic formula. I would expect you guys to do the quadratic formula, but I'm going to do some magic here. Quad formula. All right, I don't know. Yeah, so you end up with something like t. Oh crap. Let's see. T equals 7.96 seconds, which I got out of the textbook, and I'd let you guys check your answers too. So that's what I'm expecting. I hope that makes some sense. Maybe that's even useful. Going back up, you can see the problem there. So if you have trouble with this, just come by and I'll show you how to do it. I did this twice, so this is my second run, so you'll probably do the same thing. I'll teach you how to do it, and you practice it, and then you'll say, oh, I made a few mistakes. You try and fix a few, you make some new ones, blah, blah, blah. All right, that's it.